Hi! In this lecture, we will assess the accuracy of the first stage of our LGD model. For starters, we'll save the LGD target stage 1 test data frame in a temporary data frame. Then we'll reset the index of the temporary data frame. Finally, concatenate the temporary data frame with the array with estimated probabilities turned into a data frame. Let's name the two columns of the data frame with actual values and predicted probabilities LGD target stage 1 test and y-hat test proba LGD stage 1 respectively. Finally, I'll set the index as equal to the index of the inputs data frame to make sure we don't lose that information along the way. Great! Now we've put together the actual values of recovery rate being 0 or greater than 0 and the estimated probabilities. Therefore, it's easy to calculate how accurate the model is using the same methodology we did it for the PD model. First, to make it easy to choose and change the threshold for classification based on estimated probabilities, we're going to store it in the TR variable. Then, we'll add one column to the data frame, which will indicate that the predicted discrete value is 1 if the estimated probability is greater than the threshold and 0 otherwise. In the end, we will compare this column with the targets. Alright, now from the actual and predicted discrete values, we can construct a confusion matrix as a cross table. We want to put the actual values as rows and the predicted classes as columns. Let's put a label actual for the rows and a label predicted for the columns. Okay. The confusion matrix could certainly look better. As you can see, at the default 0.5 cutoff, 1,552 zeros are currently classified. However, a lot more, 2,210, are incorrectly classified as being greater than 0. As for the ones, 3,908 are correctly classified as being greater than 0, while only 978 are incorrectly classified as being equal to 0. The overall accuracy of the model is about 63%. Overall, the model is not that great. As you may remember from the PD model, accuracy at a given cutoff is not as informative for model performance as the ROC curve, which shows the true positive rate as a function of the false positive rate, essentially covering all possible cutoff points. That is why we'll calculate it. To see the ROC curve and to calculate the area under it, commonly known as area under the curve, we need to import ROC curve and ROC AUS score methods from sklearn metrics. We'll use the same methodology we use for the PD model. Now let FPR, aka the false positive rate, TPR, aka the true positive rate, and thresholds equal ROC curve from the actual values and the estimated probabilities. To visualize the ROC curve, we must plot FPR on the x-axis and TPR on the y-axis. In addition, let's plot the diagonal. Put labels on the axis and a title on the graph. Excellent! Finally, to calculate the area under the curve, we use ROC AUC score from the actual values and the estimated probabilities. The area under the curve is about 66.75%. Again, good, but not great. However, the important thing here is to remember that we're going to use this model as the first stage of estimating LGD. Therefore, it is far more important to have a larger correctly classified proportion of values greater than 0 than to have correctly classified zeros. The reason is that at the second stage, when we apply the linear regression model, some of the values classified as greater than 0 can still be estimated as equal to 0 according to the second stage model, thus correcting the current misclassification. Alright, we have successfully completed the first stage of our LGD model. In our next lecture, we will see how to save and export a model from a notebook. Thanks for watching.